the way to calculate the waiting time is the same as?
Oh yeah. I'm not sure whether the answer is the same.
No, the answer not, but like the way to calculate.
Then those who missed the last class, then it's a little bit. Those who missed the last class but attend today's class, little bit makeup, right? This time. But those who missed both of them, today and the last time, it will be disaster. Because I understand most of the students can understand the algorithm itself, so many of the students believe yourself. So then fail to answer during the exam. Because you didn't practice with your own hand. So that's totally different. Why don't you solve the problem with your own hand? Do not solve the problem with your eyes. You may realize the only difference between the shortest job first, shortest remaining job first is whether you consider this one or this one. Okay? That's the only difference. Okay. Before you leave, why don't you submit your the answer with your ID to the GA. Okay? G, why don't you collect, then the mark with the attendance. I believe your answer probably correct because it's already in the slide. Okay. If not, you should solve the problem again. Okay. So as you can see, it provides the minimum average waiting time. Why? Because it will execute the job which has the minimum amount of time. So it will guarantee the minimum waiting time. Okay? The main problem of the shortest job first, what is the main problem? Switch. So what is the priority of the shortest job first? What is the priority? What do you consider? CPU burst time or not arrival time? Arrival time is the first come first serve, right? CPU the shortest job first or shortest remaining job first, you need to consider this one. In other words, what does that mean, CPU burst time? You should know how long it will take to be completed. Okay? Can you know how long it takes? One process is until the terminate. Practically, it is not possible. Please, we have the almost done. So, one more thing. One more time. So, what is the priority of the shortest job first? So you should know not arrival time, so burst time. So you should know how long for each process to be terminated, how long it takes. So do you know how long it takes your process is done? It's not possible actually. Sometimes even though you learn the same program, same algorithm, same the status, sometimes it takes a couple of seconds, sometimes 1 minute. It's a barriers, okay? So it's ideally perfect to get the minimum waiting time. However, practically, it is not possible. How can we? Then, why do we consider such the shortest job first? How can we implement? Is it just for ideal case? There is a way to guess CPU burst time. The operating system uses a lot of such a educational guess, experience guess. Based on the experience, we will guess how long it takes. Okay? So that is the idea of this one. We will define tau. Tau is the time to take. Okay? Tau. That time is considered you can see the n equal 1. N plus 1. Actually. N plus 1 is based on what? Previous Tn, previous time. The problem is, how can we decide this variable? Depending on this one, you can guess the next time. So, for example, in case of the start, okay, if alpha is 0, the next one is the same. But in case alpha is 1, the next time is the alpha times the Tn. This is much more important than your attendance. Believe me. Okay? Attendance is usually the variation is less than 1 point out of from your final grade. But the CPU scheduling determine the project, and I guarantee 30% of your midterm exam from the CPU scheduling algorithm. It's easy to make the question. Don't you think? That's the easiest way to make the question. I can just list up the process. So please pay attention to this algorithm. Okay? So you can see the n plus 1 is the next tau means it's the next term. So we are going to consider discrete time. 0, 1, 2, 3, 4. I know time is continuous data, but there's no way to handle the continuous data in computer. So we divide the time as a discrete value. 0, 1, 2, 3, 4. So can we guess the next time? It is based on the previous state. So we are going to adjust. So after next time slot, we know how long it takes. So we adjust, kind of. Adjust what? The parameter value. Okay? By increasing, decreasing the alpha value. Okay? That is one of the naive way, okay, natural way to guess the time. It's called the exponential averaging. Actually, it's pretty much, this is the CPU burst time, but using exponential averaging, we can actually guess, try to convert it to the real time. Okay? So this is the way to utilize CPU and shortest job first and shortest the remaining job first. The next one is a priority. Priority, we will assign the priority value, which is used in real operating system a lot. What about the Windows, the operating system? Did you realize the priority of each process? If you go to the task manager, you can actually change the priority. Normal and high and low. Okay, one more. Right? Correct. Yeah. The task manager. So if you select this one, oops, my computer stopped again. Oh yes. You can see set priority, real time. High, above normal, normal, below normal, low. That is a priority. Okay, we can explicitly assign the priority for each process. Okay? Then, based on that priority, we can select the next one. It's the easiest way. Okay? Problem. I want to run all the process as the highest priority. Then what about some processor who has the low priority? Never get chance. Always. It's not only for this scheduling problem. If you are using any priority-based one, it has the same problem. That is the starvation. Lower priority may not get the chance. How to address that problem? There are several different ways. One of the ways is the aging. Aging means if within certain amount of time, if the process cannot get the chance to use the CPU, increase the priority, next level, next level, next level. Okay? Eventually, the process will get the CPU resource. So, next class, we will see the example of such a priority. Okay? Any questions? Before you leave, why don't you submit your attendance check? Actually, answer is the same as the shortest job first. Okay?